Okay. That, okay. Hello everyone. Today we'll talk about GPU and shaders, mostly about what is it, how does it work from inside. So firstly, actually, we want to dig into the how GPU architecture really working, is really working, like used in NVIDIA Titan and so on and so on. Okay, let's start from the agenda. I will tell about myself a bit. We will talk about GPU architecture. We also will talk about DirectX graphics pipeline, how actually model or vertices are procedured inside the visual engines. We can say that. Next, we'll talk about shaders. What is it? How we cook it, and so on. And the last thing we'll do is actually workshop. You'll code your own shaders. Well, firstly we'll code our together shaders, and then you'll be on your own home. Okay. Well, my name is Wilhelm. I actually got a degree in Innopolis in computer science, bachelor's one. For my thesis, I worked with GPU for JavaScript engine. So I do know how something works inside the GPU. And actually, I have about 2 years, maybe 3 years of indie GameDev experience, including some shading. Oh, actually, it's high-level shading, but don't really care about that. Okay. Also, I like computer games. I've been playing around from maybe 20s and so on. So we have 4 action RPGs. Oh, let's say that. And what we see here is actually tons of shaders. Everything like here, or maybe shadow here, lighting here, and shadowing here, etc., etc. That's all the shaders. And during the game development progresses, the shaders will evolve as well. Okay, let's start with GPU architectures. We know that CPU have like this kind of structure. We have control units, other arithmetics, some cache, tons of cache maybe like L1, L2, L3, etc. Dynamic RAM and so on. For GPU have actually one dynamic RAM as well, but actually hundreds or maybe thousands of kind of CPU cores, which allows us to use parallelism. Well, I would say what is parallelism first? It's when you can execute your code, maybe some piece of programming stuff like really in parallel, not just concurrent when one follows another for maybe kind of scheduling, but really parallel where we go synchronous. Really good. Okay. Any question on this step? Okay. Yeah. Here we have example of some NVIDIA card. We won't take dig up, but I want you to see. Well, this are multi-cores. This one's like CPU cores with a DRAM up there somewhere. Oh, yeah. Bottom one. Main CPU memory is outside of GPU. And tons of, not explain it, but utility stuff for GPU working as well. Okay. Next thing is actually pipeline. Here we have a bunch of stuff, and we'll talk firstly about input assembler stage. It's like, where is my mouse? Here. It's like here. It's responsible for supplying data for the pipeline. Actually, it comes from CPU, like everything else. Well, that's it. The next step is vertex assembly or vertex shader stage that processes vertices like transformation, skinning, lighting, shadowing, and so on. Vertex shader up here always takes a single input vertex, like just one vertex. It doesn't actually, as I remember, takes all the vertices on your model and produce a single output vertex as well. So one here and outputs one here. As we can see, these ones are multiple, like there are multiple vertex shaders. Just to note, every yellow, green, I don't know, rectangles are programmable unit. It means the programmer, like us, like high-level programmers, can really deal with this shader components. We don't mess up with vertex assembly or maybe rasterizer or blending and so on and so on. We don't really work with textures directly, like and frame buffer as well. We work with vertex shader, geometry shader, and pixel one. Okay. The next step is geometry shader stage that processes entire primitives. Its input is a full primitive, like n vertices for n gone. In addition, each primitive can also include the vertex data for any edge adjacent primitives. Like, what's that? So, for example, we have one vertex here, but we want actually to have our model to be kind of separated, maybe some cool dual weapon, maybe akimbo and so on. So we have extra data for both of them. Okay, next. Given an output primitive, the geometry shader can discard the primitive or omit one or more new primitives. So as I said, we can have multiple primitives like these ones to have one whole model, like 3D model mesh. Next thing is, I think is here. A stream output stage is designed for streaming primitive data from the pipeline to the memory on its way to the rasterizer. Data can be streamed out and or passed into the rasterizer. Data streamed out to the memory can be recirculated back into the pipeline as input data or read back from the CPU. Okay, please raise your hand if you got anything. Good, I didn't as well. Let's start again. Stream output stage is designed for streaming primitive data from the pipeline to memory on its way to the rasterizer. Okay, we have this maybe bus or something that really just working with outputs of geometry shader output and work with texture channels. What the texture channels are is actually your it's your visual video card dynamic RAM, I suppose. Like you have this suffix of GPU, like 8 gigabytes. I think it's this one's frame buffer and texture. Like you can have 4K quality textures on your video card, just to support up somewhere up there. Okay, the next thing, data can be streamed and are out into the rasterizer. Okay, after some textures loading and maybe some extra data from frame buffer, we can load it to the rasterizer. We'll talk about rasterizer a bit later. Data streamed out to memory can be circulated back into the pipeline and as input data or read back from CPU. Okay, so we actually can have this output not only for rasterizer or texture, but also to the frame buffer and our input assembly. So actually you can have some cycle, not cycle, but loop. Okay, back to the rasterizer. It's responsible for clipping primitives, preparing primitives for the pixel shader, and determining how to invoke pixel shaders. Well, it's almost about how do we work right now. Back then, about maybe 10 years, 20 years, we mostly worked about with vertex shaders. Now we work with per pixel graphics. Well, next pixel shader receives interpolated data for a primitive and generates per-pixel data such as color. For example, we have completely black screen. Then for each pixel, we have the function that applies to it. It's mostly like that. And I can say we will work for workshop in this stage actually. Well, mostly. Well, output merger stage is blending here and here. Is responsible for combining various types of output data, like pixel shader values, depth, and stencil information, and so on and so on. Well, actually, I would like to know how interesting it was for you. Please raise a hand if you heard me, and if you got me, and if you want to dig it into again. Oh, you're perverts. Okay, well, I don't really like it. Okay, what is a shader? It's actually a question for us. For you, not you, not us. What? Okay, what area it applies to? Like.
It depends on the type of shader. Like vertex shaders applies to vertices, and they get the coordinates.
No, a bit more abstract and high level. Like maybe it's a code or something.
Cool. Well, okay. It's like a script that is uploaded.
Okay, so it's a script. So it's just code of piece, piece of code. Code of piece. Okay. Something else? We have one for now.
Piece of code from GDI.
Yep, we can say that.
Without special language, shader language.
Well, it's actually interlayer between GPU and programmer. Well, okay, we can say that as well. Something else?
In general, is to beautify the game.
Well, it's the purpose, not what is the shader. Well, who I am and why I'm here, yeah, okay, it's for beautiness and something.
It's a piece of code that is efficient for parallel execution, so it does not interfere with other.
Actually, you can write any kind of code, not any efficient. Well, you can write bad code and it will be eaten by a GPU anyway. Okay, I would actually like to hear others, actually. Like, we have...
It's just a program for GPU.
Your turn, yes.
Something that changed your image on the screen.
It's a GPU. Let's change something on the screen. Well, CPU, GPU, and so on. It's interruptions. Okay, others?
I agree with Anton.
Okay, Nastya? Andrew? What? Nice, guys. Okay, we said about, well, we almost said anything about and everything about IT part, like GPU, hardware, software, and so on. But we forgot about two main things. First is design. What do you want your shader to be like? Yeah, to beautify. How? Will it be some pixel art? Should it be some rasterization? Should it be realistic ones, and so on, so on. The most important part, I think, is mathematics. You can't you can't do anything without linear algebra and some optimization, since, well, you will have some kind of rust which will freeze on your PC and so on, so on. Well, okay, the third part is IT piece of code of piece, yeah. And about circuitry, we have a GPU hardware, some architecture, and so on, so on, so on. Well, we must work with the third part, but I suggest you not to forget about the first ones as well. Actually, what we can do like that, from some shitty graphics of Java to some beautiful ones on Unreal, maybe. Okay, well, just example. Okay, I think we're done with the theoretical part. Let's start with the practice. Please, if you have Microsoft Windows or something, go to the shader tray, come new. While you do that, I'll tell you about basics, maybe. Okay, we'll work in high level shader language, HLSL. It has C-like syntax. We'll mostly work with float, how to say, types of data. Since, well, one thing to add is that GPU has a limited number, well, limited set of types of integer, floats, and doubles to work actually. Back then, some years ago, we didn't have even double 60, for example. Okay, we'll actually work with 32-bit colors like RGBA. We'll talk about some UV and resolution, maybe channel and timing. Okay, I suggest everyone to run their own engine, well, their own shader tray, and we'll start with styling. What we want to achieve is something like that, I suppose, like multiple tiles, completely configurable. Like we want to change the orientation, so on, so on, so on, so on, to get, well, okay. Okay, I got it. Like this one, maybe. Something like changeable, configurable, blah, 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 blah. Okay. Just select. Okay. I don't see anything. Yeah. Yep. Okay. We actually have this picture. So what we're going to do is firstly delete all this unnecessary stuff. Like, it's cool, but we don't need it for now. Yeah. I see nothing. Just really nothing. Okay. Oh, cool. Okay. First, what I want to do is actually to define our UV scheme. Well, say UV. Let's talk about. Wait. Let's talk about input and output parameters. Like that. Так.
You can change the font with the right left column, or the right bottom column.
Hmm?
You can change the font with the right bottom column.
Yeah. Better, not better. Okay, UV is actually an integer, well, a float between 0 and 1. It actually tells us where the our pixel is. For example, we have this one is 0, 0, and this one is 1, 1, for example. This one will be 0, 5, 0, 5. About input and output for our function. For an input, we have just for our fragment coordinate, like not from 0 to 1, but from 0 to our screen resolution. For example, here will be 0, 0, and here will be 0, 1000, blah, blah, blah. And what we can have here is like that. Actually, we can do it like that. I hope it works. Let's say that. Okay. We have here just typical C style language. We'll just talk about if well, let's see if it works. Nope, it doesn't. Okay, let's try this thing.
Or equal to the column.
Right, right. Good. Okay, what we have here is something like, oh, nice. And here we can have, for example, uv.y. Okay, our RGBA channel is represented by x, y, z, and so on, so on, so on. So we can actually, well, we can work with both ones, or x. It's just for simplicity. Well, nice. Okay. What I suggest you is it stable? Like, can you see this code and so on? No, I hope so. I suggest you to something like that. X is UV, just to make our code a bit simpler. And now we have something like this. It will be just a bit. Okay, and don't forget to actually comment your code. It's very important, but we won't do it now. It's not very important right now, but in real life, do it, like something. Okay, first what we want to achieve is tiling. So let's define some tiles. Tile X, let's say it will be 6, and float tile Y, it's 10. Okay, your idea is how to apply something, well, our tiles to our color. Okay, I will say one thing actually. This piece of code is running for each pixel on your screen. Well, you know, if you have 60 by 60 monitor display, it will be run 60 by 60 times for each pixel. Well, not for each pixel, that's just for each pixel. What we have for now is quite good FPS. Okay. What we're actually gonna do now is have some delta for also. I will show, and I think you'll understand what I mean. Alex, launch that one. it will be our step for maybe loop or something. Well, let's actually color like this one, so we can actually work with our color instead of fragment color. Okay. If you don't follow me, please say it. I will repeat something, I will explain something, and so on. Color. Right. Just for. Okay, next thing, what we want to do is quality image italics plus. No, let's do this thing. Make more complicated. Don't forget about your code styles, etc. Let's see, color. If x less than DirectX transformer, we have color x, y. Can you do this? Actually, you can do something like maybe this. I just hope it will run. Nope. Okay. Just let us see what we can achieve right now. Well, actually, it doesn't work as intended. Good one. Now do the thing for both axes, like this one. Okay, can someone say what's the problem here, guys and girls? What's the problem for this code? We have actually just a plain screen like up here. What's the problem? Well, okay, we have just a similar, maybe like that.
Red channel is already at 1 and max line. What if we have substitute? Our red channel is already 1. So what will change?
Good. Good. And yay! It worked. Perfect. And now, how I'm going to, I want to, if it works, for example, like that. Yay! What's now I got it. Yay! We have gradient. Yeah. Cool. And now what we're going to do is actually for the another axis for y. How are we going to achieve it? Any ideas? Just to repeat the loop or something. What? Well, you can show if you want. That's why we need comments. Is this better? I'm done. Okay, good. That's good. And here we have our tiling step. Step 4y.
So if we change tile Y, it's nothing is changed, right?
Hmm?
If we change tile Y, nothing is changed.
Yes, because we didn't apply something to tile Y. Okay. And the question, how are we going to do something with tile Y? Which for now we have just X. Hmm? Okay. Well, okay. What are we going to do here? Well, let's stick with the same constraint up here, for example. Actually, we can do something like that, I suppose. Yeah, cool. And for example, color dot G plus vertex. Good. Well, there, twice. Let's compile. Yay, it compiles. Yay! Well, it doesn't work as intended, I suppose. Let's say the following way. Nice.
Why don't you do it in an outer loop? It's like,
I know.
yeah,
It should actually work much better.
with the tile size.
Hmm?
Yeah. Because we have the same.
What?
The tiles are basically squares, but they shouldn't be. They should be.
Let's say. Okay, where did I mess up? Yes. I didn't get it. We have 20, and here we have, for example, 6. Let's stick with the. Hmm? Hey, what's the problem out here? Can anyone say it? For example, if we do something like that, will it work? For example, nope, doesn't work. But it. Well, I did it. I just want for you to understand it. For example, Okay.
Am I right that the color is vector 4 because we have RGB and alpha, right? Yeah.
Mm-hmm. Okay. What's actually the problem up here? Color, maybe. Oh, here we can. Let's try this one. And nope. Yep. Well, it works better. Simple 6 by 6. Well, does it work or not? I didn't get it. I mean, does it work? Beauty? Yeah. Well, what did it change? Okay. here we have such a code. Yeah, we have two loops, one inside another, one simple constraint, one single if, and some changing. Yeah, frag color is fragment coordinate. Frag color is our output. It's like we have coordinate and then we have output color for this coordinate.
And in this piece of code, it's updating each frame, right?
Yeah.
Okay. Do we need two loops for it? Cannot we just calculate the color in small formula?
What?
Because it's so one pixel, but we use two loops doing it. Maybe we can calculate the color of the fragment color without loops.
Okay, how?
Uh,
Well, it's okay. Let's try it. Using mode is okay. Like, can you show us? Well, come here. Just I didn't say it's bad or you interrupt my presentation. No, it's okay. Just let's make some optimization here because, as I remember, our code isn't so efficient. Yeah, it's well, okay. Well, when I had it at home, it was like 30 FPS. It was
Actually, it would be like a 2 FPS.
okay. Let's make some gradient. Yay! Yeah, okay, we got it. Yeah, we certainly need to somehow optimize our code because. Wait, I need to. Just wait a second. I will just read something. Yeah. I don't see anything. Maybe saying something. Okay. How to? No, yeah, we have files up here, but it doesn't work for some reason. I don't understand why WebGL isn't found it, because.
Yes, I have a solution without loops. We basically do the same stuff.
Yay! Can you show us?
Yes.
I mean, here.
Yes.
I'm not sure if it's cool. I mean, cool to work for my position because I have some problems. What is sale?
Round down.
Okay. Well, well, it works. Okay, cool. Okay, we have some more efficient solution up here. It's perfect for now. And I forget about it. Okay, I mean, where is it? Where is the mouse? Okay. Color dot will be like. Can you show me again because I am really poor memory, or just. DX. So we have DX up here. Sale is some kind of bottom, yeah, round down. Here we X, what would have.
Sale is round up, yes, sale is round up or round down. But it doesn't matter how either sale or flow will be visible.
I see nothing. I feel like Jon Snow. I see nothing. Not really better. What? That's better. Oh, okay, that's much better. What was that? Okay. Right, sail, Y. Y. Okay. Well, it compiles. Everything good? Okay. And where is? Can we have? Yeah.
I think one right is easy.
Didn't this always happen actually? Okay, this works. Actually, we can.
Вот смотри, out.
Okay. I just hope I can somehow.
В данном случае это значение красного, синего, зеленого цвета и альфа.
Вот два такого, Колор красный канал, зеленый канал.
Понятно. Не, вот как она вот именно эти два? То есть ты один раз присвоил какое-то значение?
Вот каждый пиксель присваивает.
Она, получается, промежуточное значение еще вводит экран?
Okay, I need
Каждый
to.
пиксель обрабатывает, я понял. То есть это функция, то есть она называется для каждого пикселя. Да, вот. Да, то есть она где-то сверху. Если она называется для каждого пикселя, тогда одно и то же происходит. Почему это разные цвета?
Почему одно и то же?
Okay, I'll just restart the browser because my something doesn't work actually. Now it should. And now it should, I say. No, it doesn't should. Okay, what's wrong? 12, cannot convert. Shouldn't see anything. But I hope I will. And connect. Yeah, right. Good. Yep, good. And we have something. Okay, let's check it. Yep, does work. And here we can have something like not. Yeah. Okay. Let's say a bit more. Yay! We have it. No lagging at all. Which one? Check. I missed. Yay! Nice gradient from blue to red, from black to nothingness. Okay. Did we do this? Everyone? Good. Okay, next thing is circle in the center. It will be a bit more problematic. Okay, let's. Guys, do we need to save this code of the all of our code, or I mean, do we need it, or we can reproduce it next time? And so.
Why not?
Okay. Well, actually, you can. GDI, how to say, optimize styling. Yay! GDI team styles. GDI optimized version of parameterized tiling. Yay! Submit. Yay! Okay. We have this code. I just saved it. Let's start with a new one with circle in the center. Who remembers the formula of circling, of circle, of sphere, or something? Yeah, come on. Nope. We have, yeah, like x, and so on, but first, like 2, UV is fracart XY by eye resolution. By the way, eye resolution is real resolution of your viewport, as I remember. Float x is uv.x. Float agric is uv.agric. Our x will be like maybe x minus something. The center float. Float. Oh, sorry. Better?
Yeah. And also doesn't remember how we write a square function here. How do we write power function? Raising to the power is a relevant function.
Kind of. Okay. I just need to remember how it is now. Okay, from this step we have one interesting thing, actually, and I will show you. Well, here. Where am I? Yeah. Okay. I did it wrong a bit. We need to bit centering, so it's like 0.5 minus x, not reversed. Next thing is distortion. Distortion from second. Or it's actually, yeah, I can go with distortion or circle. And let's find one more. Is time. Float timeout. No. Timeout. And remember one thing: try to use cosinus, not sinus, because sin is sin. Don't be a sinner. Well, it's just a bit more simple to work with cosinus, cousin arrays in mathematical perspective. Just this one. Okay, and let's say frac color. What am I doing? Yeah, it's okay. It's okay. And for color will be 0. Well, I'll say 0. 0. And let's say this from circle. 0. Actually, I can't really say what we did here. Well, we shall see. Actually, compa. Right. Here. Actually, we can slow down with our parameter up here. No, just slow. Well, you can use this for fading out and so on. Just so this thing is really easy formula, easy to change something. Just changing the parameters will get us the result. Tints. Well, let's make some sunrise, for example. Station from center, G. Okay, let's look here. And well, it's not sunrise. It's something else. Okay, I messed up. Yeah, that's better. And so on. Maybe we can even minus 1. Well, minus, let's say, yeah, nice effect. Okay, give a name. Circle GDI. Yeah, circle GDI archive for circle. Okay. Do we have this code? Do we understand how does it work, or something? You can actually do something more interesting right now. Just let's be. Just let's us be a bit more funny, and just to check it. What? I don't know what does it do, but well, maybe outer, maybe like that. Another level of something else. Well, you understand why we use power, not just for efficiency and something like that. You just can play around with it. Okay, let's say we have one thing. What will we do? Whoa, nice. Well, let's say we have 6. No, again. So now you can have something more like Flash, maybe some Sims for some Sims game and so on. Well, do you know? So we have it now. You can actually say in your CV, I can repeat Sims shaders. Actually. Okay. The next thing I want to do is actually slider. We can do it right here. To slide this thing like, I mean, slide from horizontal or vertical axis. Let me remember. Well, let's try something like. Okay. Footer X. GB. We'll just play around a bit, nothing serious. Actually, I believe I can just copy paste it. Yeah. The only thing we change here is like time shift. So we can have multiple colors following one to another. Let's G. Well, actually, it will be more interesting. Hope I didn't mess it up. Well, I did. Okay, what did I run? Nothing like. Sinus T minus air definition. Right definition. Float air. Ah, stupid me. Okay, sorry. And should be better. Yeah, it is better. Okay, maybe it's not what I've tried to do. Let's stick with our circles, not something. Yeah, we can say that. Okay. Well, you have party. Actually, I just want to. Yeah, just I forgot to add epilepsy warning. Sorry, but well, you can have actually 0. And now we have some cool police effect, maybe. Okay, let's say it needs more faster, maybe. Okay. Well, changing our phase shift should get a bit more result. Oh no, bad girl. 4 maybe. Will it work better? Yeah, a bit better. Anyway. Just for your granny. Okay. For now we have something like slider, circle, and something else. Possible tiles. Now we have actually two things. Where am I? To do. We can try to make some fractals and achieve some cool results like I will show you. Wait, I need to save it first, I suppose. Loved. Oh, and just playing a bit with existing things. Well, for example, this thing. Actually, well, that's the code for a cool effect. If you want, we can just go through it. If you don't, we can play around with some psychedelic things. I hate people for this. Yeah, that's better. Okay. I suppose we don't need it here. We have it here. And tons of not so pleasant code. Okay, let's just make it a bit. Okay. Didn't change nothing, but still, actually, this one. And let's. Where's our headers? Does anyone see this variable definition? Because I don't.
No.
Here, defining. Yeah. We actually can have like struct blah blah blah, and really defining the struct with cstyle and so on so on. We can have this function, so on so on so on. Like let's make a cool function like float square float base return. Oh, okay, base by base should be more efficient. It compiles. So we have a cool function square. Let's say for iteration we have maybe 2. What will be? It should be very simple. Yeah, very simple thing, but still cool looking, I think. What about a bit more values? Okay, it's I'll just play around. Or it just made quite nice. 55. And if we just want our thing login is something like that. Yeah. Oh, 30 FPS, just like Rust. Yeah, cool. Okay. So, do we play with it, or we can have our psychedelic things?
I thought it would be an interesting experiment if we do some kind of lightning effect.
Oh. The problem is I don't have WebGL, actually. I'm not sure if I can do it in 2D. like GDI. Well, it can be, but I don't know shaders so well. Actually, I can say I know low-level shaders as much as you do, like just a bit. So sorry, not today. Well, about bonus, actually, we can have like here we can work together with lighting effect. We can try to do our overlay for DirectX. I didn't do it, but I think it's kind of easy. I saw the code. So it's actually up for you what are we going to do now, or we can just say, oh, it's already 2 o'clock, we go home, for example. Well, we just made it for 1 hour, actually. So it's up to you guys and girl, what I'm going to do. Okay, when I say it's up to you, it applies, I suggest you to say something.
Please show the code.
Hmm?
Show the code, please. This code.
Sorry.
Thank you. It works.
Okay, I think I will stop recording right now. That's all for now. Because I want to eat. We can meet a bit later.